Okay, so the answer number one is B as in boy. There's a positive correlation between the size of a hospital and the median number of beds that patients remain in the hospital. Does this mean that you can shorten the hospital stay by choosing to go to a small hospital? Um, Not necessarily, because again, correlation is not causation, just so you know. So I get rid of D and E and C as well. Who cares if it's negative or positive? It doesn't really matter. But we do see a positive correlation, of course, right? Like that, yeah. The size of a hospital increases when you have a longer stay in the hospital. But the positive correlation is probably explained by the fact that seriously ill people go to a large hospital. And that's probably a lurking variable. So remember we talked about that a while ago. I remember you guys did a great job identifying those a couple weeks ago. For number two, we got B as in boy again. And so if we read this kind of carefully, it says here that a delivery service places packages in large containers before flying them cross country. These filled containers vary greatly in weight. Suppose deliveries airplanes always transport 2 such containers in each flight. The 2 containers chosen so their combined weight is close to but does not exceed a specific weight limit. Your random flights with these containers taken and the weight of each of the 2 containers on each flight is recorded. The weight of the 2 containers in the same flight. Yeah, that's a tricky one. The reason why it's going to be B, because you have 2 containers, right? And you're putting some items in one, some items in another. The thing is that sometimes you can put more in the other and less in the second one, right? Like, so if I did a quick schematic, like say these are containers, right? And say like this has a bunch of stuff in here and this has like not so much stuff. Or it could reverse, right? This could have not much stuff, and that could have a lot of stuff. So it's going to be a negative correlation between those two. And that's why it's B. So you just have to kind of extend yourself a little bit there. For number 3, that one's going to be D as in dog. Remember we talked about what to look at? We really just focus on all this and this. All else we could ignore because we haven't really done the other stuff yet. There's a residual, and they're saying that the circled point represents roller coaster in the Philippines maximum height 70 feet. What is the observed speed this roller coaster is closest to? Okay, so the residual is about 12, I'd say, perhaps. So 75. So a height of 75, that's what you observe. And remember, residual equals predicted actually, no, I take it back. It's observed minus predicted. My apologies. And so what we're seeing here is that we have a residual 12 and we're observing 75. So our residual, or sorry, predicted would have to be 65 to make that work. And that's why for number 3, wait one sec. What am I doing? Give me one sec. Okay, the observe is 70. I don't know why I wrote 75, my apologies. The observe is 70, and so the predicted. So if you were to solve for the predicted, it'd probably be about 58, roughly, if you kind of move things around. The 55 is close enough, so that's why we go with D. It's hard to tell what that residual is exactly, but we do see that the height is 75, so that's what you observe. Actually, no, I was right in doing that. Hold on a sec. Give me 1 second. Oh, never mind. You do say it's 70 right there. I was just looking at this, but okay, that's just confusing. I'll be more clear on this, but anyway, it's close enough to 55. So remember, residuals observed minus predicted. So you have negative residual if you go below the predicted line, and of course positive if you go above. And number 4, the answer for that one is E, as in Eric. So all 3 of these are true. So there is an outlier for sure right here, because most of the data is going like this, but that's way off the reservation, right? Definitely a positive association because the slope looks positive. And as the height of chair increases, the volume of usable lumber increases. Absolutely, all three are true. Let's go to 5. Now this one's going back to old stuff again. So you might remember z-scores, right? Z-score was x minus x bar over sigma. So you're apparently it takes you 35 minutes. So student at least some H1 was probably the student will arrive at the campus later than 9 a.m. So let's first find a z-score for 35 minutes. The mean's 30, and that's 5. So you get a z-score 1. Now remember, on a normal distribution, here's your mean. This would be x bar plus 1 sigma. So all this is going to be 16%. So if you want to be greater than 1 standard deviation, you're going to be 16% of your data there. And that's why the answer is going to be E for 5. And remember, you could use a calculator, or you could do norm dist in the Google spreadsheet as well, or you could do normal CDF in the calculator. I believe that's correct. Yeah, normal CDF. Here we have a stem leaf plot. So for example, machine A, so what are we looking at here? We're looking at 40 batch of each of 2 machines, the number of defects. So one machine has 11 defects. Here it has 47 defects. For machine A, it could have like 18 defects, or 18 defects 3 times, then 19 defects 2 more times. And it gives us the median for each of those, the minimum, the maximum, the quartiles. So again, it's just old stuff here. So the answer for number 6 was C's and cat. The data of value 47 is an outlier in distribution. Yeah, I think that'd be safe to say, because remember, to be an outlier, you need to do Q3 plus 1.5 times IQR. Well, what's your IQR? Your IQR is going to be 10.5 here. Multiply it by 1.5, I think that's going to be 15.75. And if you do 30.5 plus 15.75, you're totally going over there. So 4% is over that. So that's why it's an outlier. If you look at the other ones here, the output machine B exhibits less variability. Well, variability is looking at standard deviation, and we can't really compute that just yet. They seem to have roughly about the same variability, I'd say. Like you kind of like look at the distribution here, kind of turn your head sideways and treat it like a normal distribution. So I wouldn't say that one. The mean number of defective chips for machine A is more. It is, well, actually, we don't know the mean. We have to calculate that. Don't really want to do that, actually. The IQR distribution, the number of defects, machine B is less. No, it was 10.5 IQR. IQR for machine A was 5. We can get that real easily. The distribution number of defect chips from machine is more skewed than machine B. They seem about the same, I'd say. In fact, I'd probably even argue machine B is probably a bit more skewed. So that's that one. Number 7 is A is an apple. The correlation would increase and the slope of the regression line would increase. The question is, if these 2 points are removed from the data. So right now, our best fit line is going to kind of look like this, I'd say. If you get these off, then I think my line would be more probably like this. So definitely my slope is increased. So it's not decreased. So I don't think these would make any sense. Or it's not saying the same. The correlation would actually get better too, because these are pretty far off most of the points. So the correlation would be improved. So I'd say A for 7. For 8, here they want to know, what can we say about that one? The answer to this one is D. So remember we talked about R squared, right? R squared tells you, so we call that the coefficient of determination. And what that means is that it helps to explain, so what's the better way of saying this? Let's say R squared is like 0.8. And so you're looking at, say, X represents, let me think here. Let's say X represents age and Y represents income. I don't know, I can't think of a good idea, but say the older you are, the more money you make, right? So you would say that 80% of the variation in income can be explained by changes in age, or by an increase in age, because it is a positive correlation, or we assume that, I guess. So here's the average intelligence watch explain 9% of the observed variability in the reading scores. So average intelligence would be X and reading scores would be Y. It means R squared is 0.09. That's what that means. So if you square root both sides, R is going to be 0.3. However, they do say that those who watch more television have lower scores. So it's actually plus or minus, we should say, when you square root. You can go to negative because it's going down. So that's why. And then finally for C, so sorry we won't get a chance to go over the free response, but if you want to come by during office hours, you can. It means a lot more of the same stuff, just so you know, and we do have explanations here, but if you want to come by during office hours or shoot me a question, totally fine. Remember, our test tomorrow on Thursday will be very similar to what we have had for the last two tests. So lastly, for number 10, sorry, 9 and 10 really quickly. 9, the answer is C as in cat. So let's see here. Mean of 11,000, standard deviation 1,200, mean of 7,200, mean of, standard is at 680, weighs that much. How much would end up to have the same standardized weight? We haven't really done that. So let's skip 9, actually. I should have realized, you want the same z-score essentially, but we haven't really done stuff like that, but you want the same z-score. That's what you're really looking for. So you want this to be separated the same from each. So if an African elephant is 11,000 mean, so you do 12,800 minus 11,000 over 1,200. So you calculate that standard deviation, that z-score. You want the same z-score for the Asian elephants, mean is 7,200. Standard deviation is 680. And you got to solve for X. So you just basically set these two equal to each other, but we haven't really done that, so don't worry about that one. And lastly, 10, remember, we don't care about this stuff. We'll worry about that later. I care about this, and I care about this. I don't care about that. Oh, sorry, I should have seen that too. If you didn't get there, don't worry about it. The 10 we cross off as well. Okay, that pretty much about does it. So if you have any other questions, you can find me during office hours on Thursday at 8:15 a.m. I'll be available then. Sorry, won't be available tomorrow. To have a dentist appointment. I am available at 2 o'clock tomorrow afternoon. I am seeing my AP Calculus students, yeah, I just have like 60 students. So just by sheer numbers, I need to offer more times to see them. But you guys are definitely more welcome to come by there and to ask questions. I would just kind of split my time if you want to do that too. But I'm available at 2 o'clock on Zoom tomorrow afternoon if you'd like to come by for that. Okay, and I think that is it.